Hello, my fabulous fifth graders. Today's lesson is on comparing decimals. Our I can statement today is I can compare decimals to the thousandths. In our first example, Luis downloaded 2 songs onto his MP3 player. Which song is longer? So, song number 1 is 3 6/10 minutes, and song number 2 is 3 8/10 minutes. One way that we can compare decimals is using a number line. We will use the number line in our classroom quite a bit while we are comparing decimals. Here is a number line where they have 3 5/10, 3 6/10, 3 7/10, 3 8/10, 3 9/10. When you plot 3 6/10 here and 3 8/10 here, you can see that 3 8/10 is to the right of 3 6/10. Numbers that are to the right are greater than numbers to the left. So 3 8/10 is greater than 3 6/10. Another way is to line up the decimal points. This is probably the most convenient and easy way to compare decimals. To do so, you must line up the decimal points. The decimal points help you to keep your place values in order so that you are comparing digits that have the same value. So you line up the decimal points. I like to say you can play tic-tac-toe. In the greatest place, the ones place, I have a 3. The ones digits are the same. 3 and 3 have the same value. So comparing the ones place doesn't help us. Our next step is to continue to compare the digits until they're different. So let's go to the next place. I've got 6/10 and 8/10. In the tenths place, 8 is greater than 6, so 3 8/10 is greater than 3 6/10. Song number 2 is longer. One thing that's very important to understand are equivalent decimals. Now, you are familiar with equivalent fractions. For example, 1/2 is equivalent to 2/4. This just means they represent the exact same value. They are equal or equivalent. We can have equivalent decimals as well. For example, 8/10, which can be written as a fraction or a decimal, is equivalent to 80/100ths. Also can be written as a fraction or a decimal. These numbers have the same value. The models show that you can annex or place zeros to the right of a decimal without changing its value. This is very important. So if I had 3/10 or I had 30/100ths, even though there's a 0 here, it doesn't change the value. These decimals are equivalent. Here's another example. We're going to write greater than, less than, or equal to in the circle below to make the sentence true. I have 8 69/100ths and 8 6/10. Now, my first thought is that, well, this one should be larger, should have a greater value because it has more digits. But that is not necessarily true with decimals. One way to make sure you are comparing decimals fairly is to annex this 0 in open spaces so that you're comparing the same amount of digits. When I turned 8 6/10 into 8 60/100, I did not change its value. This is an equivalent decimal. But now it's easier for me to compare, and I see that 8 69/100 is greater than 8 6/10. Here are just a couple of practice problems I'd like you to try for yourself. Make sure you do two things. Plot each decimal on the number line and write a comparison symbol in each circle to make a statement true. I look forward to seeing what you come up with in class. Our lesson today was on comparing decimals. Our I can statement is I can compare decimals to the thousandths.